In this video, we're going to do some real-life highest common factor and lowest common multiple problems. For example, Tom is a carpenter. He is cutting two large planks of wood, A and B, into pieces. The first plank is 24 centimeters long, and the second is 18 centimeters long. So I've just done a really rough sketch of the situation there. He needs a number of equally sized smaller pieces to be cut from each plank. What is the length of the largest pieces he can cut A and B into, bearing in mind that they need to be equal? How many of these pieces does he make from A and how many from B? Because he is cutting the larger planks of wood, A and B, into smaller pieces, equally sized smaller pieces, we can think of this as division. So we're looking at dividing 24 and 18 into smaller pieces. We should remember from last time that the numbers that we can divide 24 and 18 into are going to be factors of those numbers. And because we want the length of the largest piece, or the largest number that will divide into both 24 and 18, we should notice that we need to work out the highest common factor of 24 and 18. To do this, we list the factors of 24, using our horseshoe method: 1 times 24, 2 times 12, 3 times 8, 4 times 6, 5 doesn't go, and then 6 is a repeat, so we're finished. So we have 1, 2, 3, 4, 6, 8, 12, and 24. Similarly for 18, 1 times 18, 2 times 9, 3 times 6, 4 and 5 don't work, 6 is a repeat, so we're finished. 1, 2, 3, 6, 9, and 18. So the largest number which goes into both 24 and 18 is going to be 6. And that is our highest common factor. And if you imagine, if we cut A into 6 pieces, if we cut A into pieces of length 6 centimeters, we would have 1, 2, 3, 4 such pieces. So A is cut into 4 equal pieces, and B is cut into 3 equal pieces. And the pieces are all 6 centimeters. So final answer would be largest piece is 6 centimeters, and there are 4 pieces from A, because 6 fours are 20, B, because 3 times 6 is 18. In this example, we have a train A arriving at a station every 20 minutes. Train B arrives at the station every 15 minutes. Both trains have just arrived at the station. After how many hours will they next arrive at the station together? We could look at this situation by looking at multiples of 20 and 15, because every 20 minutes train A is arriving at the station. So we can say that if it arrives at a certain time, then 20 minutes later it will arrive again. 40 minutes from the start point it will arrive again, and then 60 minutes from the start point again, and so on. Train B, if it arrives at a certain time, then 15 minutes later it will arrive again. 30 minutes from the start it will arrive again. 45 minutes from the start it will arrive again, and 60 minutes from the start it will arrive again. So if both of the trains arrive at the station at a common start point, we can see that after 60 minutes they will both arrive at the station at the same time, which is just 1 hour. And in fact, we have worked out the lowest common multiple, 15 and 20, to do this. With these ideas in mind, here are some questions for you to try. Please pause the video, and when you're ready for the answers, press play. Here are the answers.